Let's start our next lesson on rational expressions, which is lesson 2 on multiplying and dividing rational expressions. There are 3 steps to keep in mind when multiplying and dividing rational expressions. Step 1, factor everything if possible, both in numerator and in denominator. Step 2, clearly state all non-permissible values before proceeding to simplify your rational expression. Step 3, simplify the expression by dividing out the common factors. Let's do a few examples. Our first example is 12x squared y divided by 5y multiplied by 15 by 4x. So here, I'm going to simplify our y's first. So in the numerator, I have 1y, and in the denominator also, I have 1y. So these two y's will cancel out each other. Okay, next. In the numerator, we have x squared. In the denominator, we have x. So 1x cancels out 1x in the numerator. So we will be left with 1x in the numerator. Now let's simplify these numbers. So 5 divided by 5 is 1. 15 divided by 5 is 3. Now 4 divided by 4 is 1. 12 divided by 4 is 3. So in the numerator, we'll have 3 times 3, that is 9, and also x with it. And in the denominator, we have 1, that is equal to 9x. So now let's determine our non-permissible values. So non-permissible values are x should not be equal to 0 and y should not be equal to 0. Because if our x or y or both are 0, then our denominator in this rational expression will be 0, and the rational expression with the 0 denominator is not defined. Okay, let's do example 2. Let's simplify our y's first. So in the denominator, we have 3 y's here and 1 y here, means total 4 y's. And in the numerator, we have 4 y's too. So we're going to cancel them out. So in the numerator, we have 2x, and in the denominator also, we have x squared. So they both cancel out each other. So let's simplify our numbers now. So 6 divided by 9, let's reduce it to the simplest form. 6 by 9 is 2 by 3. So 20 divided by 5 is 4 by 1. And then we have x cubed in the numerator. So we'll get 8x cubed divided by 3 as our answer. Now let's determine our non-permissible values. So non-permissible values are x not equal to 0 and y not equal to 0. Now let's do our question number 3. So in question number 3, in the first expression, we have a quadratic equation in the numerator, and in the denominator, we have difference of squares because 9 is a perfect square, right? So x squared minus 9 can be written as x squared minus 3 square. That is difference of squares. So here in the second expression, we again have a quadratic equation in the numerator. So we're going to find the factors of this quadratic equation. And in the denominator, we're going to again find the factors of this quadratic equation. Let's simplify this. So our x squared minus x minus 12. So this equation will have x minus 4 and x plus 3 as factors. And x squared minus 9 is the difference of squares. That is equal to x plus 3 and x minus 3. Okay, now factors of x squared minus 4x plus 3 are x minus 1 and x minus 3. And for x squared minus 4x, I'm going to bring x out. And inside the bracket, I will be left with x minus 4. Before I'm going to cancel out the common factors, I will determine my non-permissible values. So non-permissible values are, so here If I plug x as -3, so -3 plus 3 becomes 0, and 0 multiplied by anything is 0. So one of my non-permissible values are -3. Next, for this part here, when I plug x as 3, so 3 minus 3 is 0. Again, 0 multiplied by anything is 0. So another non-permissible value is 3. Now here, if I plug x as 0, my denominator will be 0. And for this part here, when I sub x as 4, my denominator will be 0. So these are the 4 non-permissible values for this expression. Now let's cancel out the common factors. So x plus 3 cancels out with x plus 3. X minus 4 cancels out with x minus 4. X minus 3 cancels out with x minus 3. So we are left with x minus 1 in the numerator and x in the denominator. So our answer is x minus 1 divided by x. Let's do next question. Question number 4. So in the question number 4, in the first rational expression, we have a quadratic equation in the numerator and another quadratic equation in the denominator. And for second part, we have a difference of squares because x squared minus 25 is actually equal to x squared minus 5 squared, and we can apply the difference of squares here. And same thing here, x squared minus 81 can be written as x squared minus 9 squared because 81 is a perfect square and can be written as 9 squared, and we can apply difference of square formula here. So let's simplify this. So factors of x squared minus 13x plus 36 are x minus 4 into x minus 9 divided by factors of x squared minus 9x plus 20 are x minus 4 into x minus 5 into, so x squared minus 25 is difference of squares, and we can write them as x minus 5 into x plus 5. And again, x squared minus 81 can be written as x minus 9 and x plus 9. So before canceling out our common factors, let's determine our non-permissible values here. So non-permissible values here are x should not be equal to 4, 5, positive 9, negative 9. Okay, because if I plug any of these values in my denominator will be 0. Okay, now let's cancel out the common factors. So x minus 4 cancels out with x minus 4. X minus 5 cancels out with x minus 5. X minus 9 cancels out with x minus 9. So in the numerator, we are left with x plus 5. And in the denominator, we have x plus 9. So our answer is x plus 5 divided by x plus 9. So these first 4 questions were on multiplying rational expressions. Now we're going to do a few questions on dividing rational expressions. So let's do question number 5 on dividing rational expressions. So to do that, first of all, we're going to find the factors of a rational expression. So x squared minus 4 can be written as x squared minus 2 squared because 4 is a perfect square. So this becomes x minus 2 into x plus 2. And in the denominator, we can take x common, and in the bracket, we will be left with x minus 4. Okay, there's a division sign in between. And let's find the factors of x squared plus x minus 6, and then find the factors of x squared plus x minus 20. So the factors of x squared plus x minus 6 are x plus 3, into x minus 2, and in the denominator we have x plus 5 into x minus 4. Okay, now let's look for our non-permissible values. So non-permissible values are here, if I plug x as 0, my denominator will be 0, right? So one of our non-permissible values, or x should not be equal to 0. And here, if I plug x as 4, my denominator will be 0. And from here, it is negative 5. And from here, x minus 4, if I plug x as 4, my denominator will be 0. So I already have got it, so I don't have to write it again. Okay, now, so here there is a division sign, right? In order to simplify this rational expression, we're going to change division into multiplication, and we're going to flip our second rational expression. Means numerator will go in the denominator and denominator will go in the numerator. Okay, we're going to take the reciprocal of the second expression. So let's simplify this. So this is equal to x minus 2, x plus 2 divided by, so first part will stay the same. Now here I'm going to change division into multiplication. I'm going to flip the second part. So it means this denominator will go in the numerator and the numerator will move into denominator. Means I'm going to take the reciprocal of the second part of the rational expression. So this becomes x plus 5 into x minus 4 divided by x plus 3 into x minus 2. Okay, now here I'm going to again look at my non-permissible values for this part of the question. So here, if I have x as negative 3, again my denominator will be 0. And when I plug x as 2, my denominator will be 0. So I'm going to add two more non-permissible values here. That is 2 and negative 3. Okay? So again, you're gonna look for your non-permissible values before before changing division into multiplication, and also after you have changed your division into multiplication. Means you have taken the reciprocal of the second part of your rational expression. Okay, now we're gonna cancel out the common factors. So our x minus 4 cancels out with our x minus 4. And then x minus 2 cancels out with this x minus 2. So in the numerator, we are left with x plus 2 into x plus 5. And in the denominator, we have x into x plus 3. So our answer is x plus 2 into x plus 5 divided by x into x plus 3. Okay, let's do our last question. This question is again on dividing rational expressions. So this is 2x minus 6 divided by x plus 5 divided by x minus 3 by x plus 2. So again, we will change division into multiplication and then gonna switch the second part of your rational expression. Numerator will go into denominator and denominator will move into numerator. Means you're taking the reciprocal of the second part of your rational expression. Okay, now before we're gonna cancel out the common factors, we will find the non-permissible values. So for non-permissible values, you always look at the original equation too, and then once you have changed your division into multiplication, then you look at your the second part of your expression, then you're going to apply your non-permissible values there also. Okay, so for the first part, the non-permissible values here are, if I plug x as -5, my denominator will be 0, and if I plug x as -2, my denominator will be 0. So my non-permissible values are x should not be equal to -5, -2. Now from here, I've already written x is not equal to 5, so I'm going to look here. So if I plug x as 3, my denominator will be 0. So my another value is 3. Okay. Now we're going to cancel out the common factors. To do that, let's first simplify this first part here. So 2x minus 6, 2 is the greatest common factor. So I'll be left with x minus 3 in the bracket. And there is x plus 5 in the denominator. X plus 2 divided by x minus 3. So now these x minus 3 and x minus 3 cancels out. So our answer is 2 times x plus 2 divided by x plus 5. That's it for this lesson.